This is a more general solving a quadratic equation example. And I'm going to show you how you can solve this equation of x squared plus 11x equals negative 28 once by factoring and once by completing the square. Let's start by factoring. So when I'm solving this thing by factoring, I want to get everything on one side. So I'm going to take this negative 28, I'm going to add that to the left. Because then I can get it so it's equal to 0. And if it's equal to 0, and I have two things multiplied together give me 0, and one of those two things had to be 0. Okay, so I added that to the other side. Great. I want to factor this, so I'm looking for two numbers that multiply to give me 28, but add to give me 11. So I've got 4 and 7. Now, from here, I want to set each of these pieces equal to 0. So I've got x plus 4 equals 0, or I've got x plus 7 equals 0. I'm going to subtract that 4 over. That gives me x equals negative 4. I'm going to subtract that 7 over. That gives me x equals negative 7. I have answers of negative 7 and negative 4. Factoring is a pretty fast method if you can find the numbers at work. If that's something that you don't like doing, completing the square also works, even if it looks a little bit messier at first. So I've got x squared plus 11x equals negative 28. And when I'm completing the square, I add half of that b term squared. I'm going to do that to both sides. B is always the thing next to the x, so b here is 11. This gives me a b over 2 of 11 over 2. I'm going to have some fractions here. That's okay. My b over 2 squared is going to be 11 squared, which is 121, over 2 squared, which is 4. So I'm going to take this x squared plus 11x and this negative 28, and to both sides of the equation, I'm going to add this 121 over 4 value. So on this side, when I factor this, it's going to factor as x plus that b term over 2, 11 over 2 squared. Completing the square will always complete where it's x plus your b over 2 squared. We can check 11 over 2 times 11 over 2 is going to give me that 121 over 4. 11 over 2 plus 11 over 2 will add to give me the 11. So if I factored this, it would still give me that same result. On this other side, I have negative 28 plus 121 over 4. Now, I want to be able to combine these things, and in order to do that, I need a common denominator. So I'm going to take this negative 28, which you can think of as a fraction as negative 28 over 1. And I'm going to multiply the top and bottom of this thing by 4, just so I can combine these fractions. I like the factoring way a whole lot better. Look, clean numbers, couple quick steps. Completing the square still works though. And I'm multiplying these things together. So this gives me negative 112 over 4 plus 121 over 4. Adding these, I get 121 take away 112, that's 9 over 4. I'm going to take the square root. When I take the square root, I'm going to have a plus or minus of this thing. The square root of that 9 is going to give me 3. Square root of that 4 is going to give me a 2. I'm going to subtract this 11 over 2 to the other side. So minus 11 over 2, plus or minus 3 over 2. And here are my two answers. I've got x equals negative 11 over 2 plus 3 over 2. Or I have x equals negative 11 over 2 minus 3 over 2. Negative 11 plus 3 is going to give me negative 8. So I have negative 8 divided by 2. Negative 8 divided by 2 is negative 4. If I do this thing with negative 11, take away 3, that's negative 14. Negative 14 divided by 2 is negative 7. So I have two answers, negative 7 and negative 4. If I look back to factoring, I got the same results, negative 7 and negative 4, but with way less steps. Completing the square always works, but it's often harder. Factoring doesn't always work, but when it does work, it's much, much faster. So my recommendation is at least try to factor. If factoring doesn't work, that's when you pull out the big guns. That's when you look at completing the square.